So our C value, C is equal to 23. Now, so really what we're saying is this, is that when we look up 23 on our encoding, 23 is associated with an X. So what we know is this, is that P, which was represented the I, okay, so the I is taken to C23 is taken to X, okay. And we continue in this fashion, encoding our characters. So when P is equal to 0, we get our ciphertext C must be equal to, well, it's equal to A, which is 15, times 0, plus B, which is 7, modulo 26. Well, this gives us C must be equal to 7 modulo 26. 26 into 7 goes 0 times with a remainder of 7, so C must be equal to 7. Or what we're saying is this, is that the letter A, which represents a 0, is encoded to the letter 7, and the letter 7 is a H. So what we have now is we have A, so we have C is equal to 7, or we have the letter A is taken to the letter H. And we continue in this fashion for all of our numbers, taking them and encoding them. The next number is 12, so when P is equal to 12, the ciphertext must be equal to A, which is 15, times P, which is 12, plus 7, modulo 26. So in this situation here, we have 15 times 12 gives us 180, plus 7 gives us 187. So C must be equal to 187 modulo 26. Now, how many times does 26 go into 187? So we have 187 divided by 26. It goes in approximately 7 times. So what I know is this, is that that 187, okay, must be equal to 26 times 7 plus some remainder. Okay, well, what's 26 times 7? Well, 26 times 7 is 182. What do I add on to 182 to give me 187? Okay, well, I add on a 5. So in this case, R is equal to 5. So we have 187 must be equal to 26 times 7 plus 5. Okay, our R is 5. Okay, so really what we're saying here, the remainder, that's what we're interested in. The remainder, we're always interested in the remainder. The remainder is 5, so C is equal to 5. In this situation, we're saying the letter M, which was encoded as a 12, is taken through to the encryption algorithm to the letter 5, and the letter 5 is an F. So what we have is we have M is taken to F. Okay, and we continue in this fashion. Yeah, well, we already know a 0 is taken to. Okay, 0 is taken to H, so we don't need to do that. What about 18? Where's 18 taken to? So when P is equal to 18, the ciphertext should be equal to 15 times 18 plus 7 modulo 26. Well, that means C must be equal to, let's just get our calculator again. It's 15 times 18 plus 7 gives us a value of 277 modulo 26. Okay, so when I divide 26 into 277, what's left over? Okay, well, 277 is equal to, 26 times, divide that by 26, it goes in 10 times. Okay, so plus some remainder. What do I add on to 26 times 10 to give me 277? Well, clearly we add on 17. Okay, so what we have is 277 must be equal to 26 times 10 plus 17. Our remainder is 17. So what we have is our C value is equal to 17. Okay, so 18 represented the character S. So what we have is that S is taken to 17, and 17 represents the character R. Okay. And now that we've done 18, we move on and we do P is equal to 4. So when P is equal to 4, we get C, the ciphertext must be equal to A, which is 15, times the plain text, which is 4, plus B, which is 7, modulo 26. Once again, in this case, 4 15s is 60 plus 7 gives us 67. So C has to be equal to 67 modulo 26. So the question is, when we divide 26 into 67, what's left over? Well, how many times does 26 go into 67? It goes in approximately twice. So what we know is 67 must be equal to 26 times 2 plus some remainder. Okay, so, well, 67 minus 26 times 2 gives us a value of 15, so the remainder must be 15. So 67 is equal to 26 times 2 plus 15, and our remainder is 15. So what we have now is we have C is equal to 15, our ciphertext. Okay, so now, once again, we encoded the plain text P is 4, which was the letter E. So what we have is the letter E is taken to 15, and 15 represents the letter P. Okay. Continuing in this particular fashion, moving on to the next character, which is a 2, we end up with, when P is equal to 2, the ciphertext is equal to A, which is 15, times 2 plus 7 modulo 26. Okay. 15 times 2 is 30, plus 7 gives us 37, so C must be equal to 37 modulo 26. How many times does 26 go into 37? It goes in once. And what's left over? Okay, well, we have 11 left over. Okay, so actually, if I was to do it the way we're doing it here, what we now know is this, is that 37 is equal to 26 times 1 plus 11. Okay, so this is my remainder. Okay, this is the remainder here that we're interested in. So we have our ciphertext is equal to 11. The character P is equal to 2. Okay, when P was equal to 2, okay, the plain text 2 is a C. So what we end up with is this, is that C is taken to 11, and 11 is the character L. Okay, nearly there. We have to do, I suppose, really 2 more, because we've already done 4. Okay, so we need to do 17 next. So when P is equal to 17, the ciphertext is equal to 15 times 17, okay, plus 7 modulo 26. Okay, well, 15 times 17 gives us a value of 255, plus 7 gives us a value of 264. So the ciphertext must be equal to 262 modulo 26. Okay. How many times does 26 go into 262? So divided by 26, it goes in approximately 10 times. Okay. So now what we know is that 262 must be equal to 26 times 10 plus a remainder. Okay. Well, 26 times 10 is 260. What do I add on to it to give me 262? I add on 2. So what we know is 262 is 26 times 10 plus 2. So my remainder is 2. So what we have is C is equal to 2. The ciphertext is equal to 2. From a character perspective, P was 17, our plain text was 17. Plain text 17 is OR. So what we have is OR must be taken to the ciphertext 2, which is C. So OR is taken to C. Okay. Oh, this was pretty long. I didn't think it was going to be this long. Okay. But our next character to do is the character 19. So when P is equal to 19, the ciphertext is equal to 15 times 19 plus 7 modulo 26. Okay. Well, 15 times 19 gives us 285, plus 7 gives us a value of 292. So we have C must be equal to 292 modulo 26. Okay. So once again, how many times does 26 go into 292? But more importantly, what's left over? Well, 292 divided by 26 goes in approximately 11 times. So what we know is 292 must be equal to 26 times 11 plus some remainder. Okay. Well, 26 times 11 is 286. So what we have here is that 292 minus 286 must be equal to OR. Okay. Well, 292 minus 286 gives us a value of 6. So we have 292 must be equal to 26 times 11 plus 6. Okay. which gives us our remainder. So our ciphertext is equal to the remainder, which is 6. So in this situation here, we have the plain text character 19. Okay, the plain text character 19, which was 19 was a T. Okay, so T must be taken to the ciphertext character 6, and 6 is a G. Okay, so we're just done now. So our secret, okay, is, well, it was I, wasn't it? It was, yeah, I am a secret. That's the plain text. This is the overall plain text. Okay, and the ciphertext, okay, is, well, if we go back to our first run of this, okay, where we had 8, well, we have L is taken, sorry, I is taken to X, so this goes to X. Okay, A, which was the 0, is taken to H, so this goes to H. We have 12, which was an M. M is taken to F. Okay, A is taken to H. We have S. S is taken to R. We have E. Well, we have E is taken to P. Okay. We have C. Well, we have C is taken to L. Okay. We have R. Well, we have R is taken to C. Okay. And we have E. Well, E is taken to P. And finally, our last calculation was in relation to the T, which was, if I can actually find this, oh, there we go. P is 19, which was a T, is taken to G. So our message that we would actually communicate would be, with no spaces, would be X, H, F, H, or P, L, C, P, G. And this is my secret code that we will transmit. Okay. Right, guys. I know there was a lot involved there. Okay, but the key to this particular algorithm is to choose. I suppose we know what our alphabet size is going to be. In our case, 26, and it's to choose two values, A and B. The important thing is that both values A and B are less than or equal to M. Okay. And another condition is that the value of A must share no common divisors with M, and the characters or the parameters that we chose was M is 26, size of our alphabet, A is 15. 15's divisors are 1, 3, 5, and 15, whereas 26's divisors are 1, 2, 4, 6, 12, and 26. The only common divisor is 1. That's good. And B could be anything at all, so B was equal to 7. And then we just substitute these in, along with our plain text representations, to give us our ciphertext. Okay, guys, I hope this was helpful. I know it was quite a long video, 28 minutes there walking through that. We would automate this particular process. You wouldn't be doing this by hand, but you can actually see we've encoded 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters we encoded here, yeah. And walking through and talking through this particular process took probably about 28 minutes. So guys, I hope this video was helpful. And once again, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. Okay, thank you.